All right, welcome everybody. Welcome at the 40th OpenValue meetup, approximately. Didn't do the exact math, but we're getting there. We're in person again and also online. My name is Roy Honders. I'm your host for this evening. We have two talks for you. The first one is by a Java champion, the CTO of OpenValue, Bert Jan Schrijver. He's going to talk about debugging distributed systems. We'll have a short break after. And then we have a talk by Roy Honders. He's going to talk about Google Cloud Vision and image processing. I think two really exciting topics, and I wish you a lot of fun. First with Bert Jan Schrijver.
Thank you, Roy. I would like to ask everybody at home to give a small round of applause to our stream DJ, Paco, who is going to make us all look good. Paco, you hear me all right? Good. Then let's get started. We're going to talk for the next 45 minutes about distributed systems. When I first presented this talk, this was for the Java use group in Switzerland. They gave me a slot of 60 minutes and I made the content and I thought, wow, I hope I can fill those 60 minutes. And then I talked for 1 hour and 20 minutes. So we might as well call this debugging distributed systems, the good parts. But it's also about networking. So you could also call it networking 101. Or it could also be how the internet works. So we're mainly going to talk about connections between systems, things that can go wrong there and how we can fix them. So, why this talk? How many of you are involved in some way in software development? All of you, and I see everyone at home as well. So I think it's quite fashionable nowadays to build stuff that we call microservices, right? And microservices in essence are distributed systems because they're just components running on different computers talking to each other. So even if you're developing a front end. It's still a distributed system because it's something that runs in a browser and that sends requests to a backend over a network. So my name is Bert Jan Schrijver, but Roy already introduced myself, so let's skip over this. The next 45 minutes or so, we're going to, we already talked about why, so we can check that off. We're going to talk about what are distributed systems, why are they difficult and fun. We're going to dive into networking 101. We're going to share a structured approach that I use to debug issues in distributed systems. There'll be some demos. If we have time, I'll share some more stories about things that went wrong. And every story needs an end, and this one is no what's the word I'm looking for? Exception, thank you. We're going to be talking about exceptions a lot as well. So what is a distributed system? Well, what do you do when you want to know something? You look it up on Wikipedia. Wikipedia says it's a system whose components are located on different networked computers and they communicate and coordinate their actions by passing messages. So we're talking about at least two components. They're connected by a network and they pass messages. You might call them microservices as well, but in essence, every system that's networked and talking to each other, for example, Facebook is a distributed system. So what are characteristics of distributed systems? Well, you have multiple components running concurrent and things can go wrong in different places at the same time. There's no global clock, which means that it's hard to time things or to synchronize on time. And components can fail independently of each other. So you might as well have a system where you have 1,000 components where most of them are running all right, but some of them are broken beyond repair. And as a result, these types of systems are harder to reason about. So as Martin Kleppmann says, the author of Building Data-Intensive Applications, he says it's fundamentally different from writing computers that run on software that runs on a single computer. And the main difference is there are lots of new exciting ways for things to go wrong. So what could possibly go wrong if you build distributed systems? Well, let's start with the OSI model. How many of you are familiar with the OSI model? Most of you? How many of you talked about the OSI model in the last 3 years? 2 of you. Okay, good. But did you talk to each other about it? Okay. So that counts as 3 then. So the OSI model is a reference model for networking applications, and there's lots of layers which we are not going to talk about. We're going to look at the conceptual layers that TCP/IP uses, and these are basically 4 layers. So the bottom layer is the network interface, and this is basically physical media, so Ethernet, cables, or fiber, where we're sending bits over the wire. On top of this is the network layer. The network layer is about IP and routing. And the last time I presented this talk, which was past Thursday, I expect if I would have asked the audience, do you know what BGP is? Probably no one would have known. But how many of you are familiar with what BGP is? So we learned something from the Facebook outage then probably, right? So in essence, the internet is a combination of networks, local networks, LANs, that are networked together. And these talk to each other through routes over the internet. And well, different data centers have peerings to each other that know where to route the packets if you go from one data center to another. And these peerings are vital for knowing where to find another data center. So what in essence happened at the Facebook outage somewhere this week is that Facebook, probably as an error, unpublished all their routes. So basically they deleted everything, all the routes to their data centers, and nobody was able to reach them anymore. And to fix this, well, they needed to reconfigure their routers, but there were no routes to those routers. So the problem was that they needed to go on site to type in commands to those routers to restore those routes. But the other problem was that there are probably only, I don't know, 5 or 10 people in the world at Facebook who know how to resolve those problems. And those probably don't live in the anywhere in the area of all the data centers that Facebook uses. So why it took them so long is probably because they need to get people on site, which might have been hard because their batch readers didn't work. So they might have needed to break into their own data centers. And then people who are on site needed to talk over the phone because all the internal Facebook tools didn't work as well, to basically let them dictate obscure network commands to reconfigure their routers. So that took them like 7 hours, is I'd say admirable, because it's a hard problem to recover from. So that's a network layer. The transport layer is on top. So we're talking about TCP, UDP connections. And on top of the transport layer, we have the application layer, which is about HTTP, DNS, TNS. So we're talking about protocols here. And basically things can go wrong in all of these layers, although usually we see problems mostly in the top 2 layers. I don't think many of you have had problems caused by broken network cables or network cards. You may have, but typically they are on higher levels. So a famous internet question is, what happens when you type google.com in your browser and you press enter? Well, let's have a look. I'm taking out my notebook. I'm going to draw whatever happens when I type google.com in my browser. So this is me. I'm at home sitting with my laptop. And in my laptop I type google.com, www.google.com in my browser address bar, and I press enter. So let's pause here. When I do this, what's the first thing that happens? I type google.com and press enter. What's the first thing that happens? DNS query, but there are a lot of things happening before the DNS query. Autocomplete, yes, but also things before autocomplete. There is somebody who took the time to wrote this down in extreme detail and put it on GitHub. github.com/alex, what happens when. So think a bit more about the hardware level. What happens when you start typing? Keys, yeah. So you're close. What happens to those keys? Yes. So that's the physical part, but what's the first thing that happens when a key gets pressed? So if you have a PS2 keyboard, a digital circuit closes and there's some current flowing through the circuit of the key, which will probably trigger a hardware interrupt that will trigger a process in the operating system to trigger a key down event. And if you have a USB keyboard, it's slightly different, but generally it's the same. So why am I telling you this? I have no idea, but I found it fun to ask something that you probably were thinking a few steps ahead already. So key press, and then probably the first thing that happens is indeed autocomplete. I think your browser will start looking for anything in its autocomplete list that starts with a W. So first step is parse the URL. And I pressed over it, so let me see if I can skip again with, oh, that works nicely. Then we're just going to look at the bar in the bottom here. Parse the URL. So my browser starts to look at www.google.com and it sees, okay, there's no protocol in there, so I'm not sure if it's HTTP or HTTPS. There's no path in there, so I need to probably look up the google.com domain. But first, I'm going to check my HTTP strict transport security list. That is a list of domains that are HTTPS only, which google.com probably is in there, so we're going to do HTTPS. Going to check my local DNS cache. Probably I have no DNS cache for Google on my machine. Well, probably I have, but let's assume I don't. So next we are going to query the DNS server. So which DNS server? Probably the DNS server that's configured on my laptop, which is probably the DNS server of my provider. So this is the first time I'm going to travel outside the boundary of my local network. Going to connect to my internet provider, which is Ziggo. Ziggo has a DNS server, so my laptop is going to ask Ziggo's DNS server, what's the address for www.google.com? Well, Zico doesn't know. Well, they know, but let's assume they don't know. So they need to ask the authoritative source for the domain google.com and the subdomain www. So it's going to query Google's DNS server. And Google says, well, I got you, www.google.com is 1234 as an IP address. So now my laptop knows it needs to connect to port to IP 1234, port 443. Because of HSTS, we know that it should be a TLS connection. So I'm going to connect to 1234 TCP 443, but where? Well, probably some Google data center, where probably there's an edge load balancer running that first receives my request. So on top of this TCP connection, I make a TLS handshake and a TLS connection, so it's encrypted. And on top of this TLS connection, I'm doing HTTP GET request for /. So this load balancer probably, I'm saying probably a lot because I have no idea, but probably a load balancer is going to connect to some service registry that has a list of where Google services are internally located. And the service registry tells the load balancer you need to be at this Kubernetes cluster or Borg cluster or whatever container orchestration they use. Let's assume Kubernetes. So there's an ingress, which is basically the load balancer inside the Kubernetes cluster that is also connected to a service registry. And it knows that the Kubernetes pod for google.com is located on this Kubernetes host. There's a pod inside there, so ingress routes to this host and the host routes to the pod that has the web application for google.com. So probably there's some database where we need to fetch some configuration or ads from that we also need to connect. We send the result back to the ingress, to the load balancer, and send the HTTP response back to my laptop. So step 5 was make the connection. Step 6 was perform the request. And then the final step is pass the response. So why am I showing you this? Because if you're building a system, probably it looks somewhat like this, maybe a bit more complex, maybe a bit less complex. But in all of these steps, in all of these boxes and arrows, there are things that can go wrong. So if you type google.com in your browser and nothing happens, it could be any of those arrows and boxes where something is wrong. And it helps to think about problems in a way like this, visualize them in the most amount of detail as you can, and then try to figure out which of those boxes or arrows is broken. So, where do you start if you have a problem? So I'm going to share an approach that I've used over the past years to debug these kinds of network-like problems. It's not necessarily the right approach or the only one, but it's one that works for me. It might work for you too, and it might not. So the first step is to think about what do I know about the problem. So observe your system and look at any information that you might have that can give you a pointer on what the problem is. So ask yourself, what do I know? Do I have any logging that might have errors? Any errors in the logging? Do we have metrics or tracing that I can look into that might give me an indication of what might be wrong? And then make a picture on a whiteboard and draw the path from source to target. So start all the way with the source machine, draw the path to the target machine, and think about what's in between. And focus on details, because there might be a firewall in between or a proxy in between that you forget that maybe, I don't know, doesn't support HTTP chunking or doesn't or injects some headers or removes some headers. So focus on details here and document what you know. So this is helpful for 2 reasons. First reason is that it helps you onboard others on the problem. Whenever somebody else needs to help, they can read the documentation instead of you need to tell it to them. And second, this is the basis for your post-mortem, so the problem description you write after your incident. And think about whether you can reproduce a problem in a test, because if you can reproduce it in a test, you probably have, it's a lot easier to illustrate the problem and try out solutions. If you manually need to reproduce a problem, you might have a lot less tries in 1 hour to try a solution. For example, by injecting error. So there are tools like Jepsen that are being used, for example, to test Cassandra and how Cassandra works with handling failures and re-election and stuff. And this is an interesting tool to stress test your application, what happens when there's a network error or timeout or whatever. So tools you use here are whiteboard, documentation, logging, metrics, tracing. So the Open Tracing project is one that's suggested often, where you can add, for example, correlation IDs between requests. If you have a microservices system, you can then relate a request that's coming in to other local services in your network. Test, obviously, and tools like Jepsen to inject errors. And the result might be something like this. Then second step is to try to create a minimal reproducer. So a utility or a tool or a program that demonstrates the problem as simple as possible and in the least amount of steps and least amount of time as possible. And the goal is to maximize the amount of debugging cycles you have. So if it takes 10 minutes to click and log in and set up tunnels and before you can show it to a colleague, you have only 6 tries in an hour. But if you can reduce this to 1 minute, you have now 60 tries in an hour to try to solve the problem. So focus on short development iterations and quick feedback loops. For example, you might be able to reproduce a problem with a shell script on the source machine, or by writing a really simple Java or Go program that you can quickly compile and use a script to upload to the target machine. So you have a lot of speed in trying out new solutions. Try to get close to the action. So if the problem is happening on a test server in a cloud environment somewhere, and this machine cannot reach another machine, then it makes sense to try to log in to this cloud machine, or at least go to another machine that's in the same network. Because if you might be trying it from your development machine, there's a whole different route to the target machine, and there might not be firewalls or proxies in between. So try to get as close to the source of the problem as possible. So tools you use here are an IDE, shell scripts, maybe simple Java applications, SSH tunnels, or curl. How many of you are familiar with the concept of SSH tunnels? Everyone. Then I'm not going to demo SSH tunnels. Cool. I used to work at a company where it was forbidden to use SSH tunnels. 2 people in the audience are laughing now because they had the same the same situation. I love SSH tunnels because you can do all kinds of things that people do not want you to do. So next step is to look at the client side. So if you have a client that's connecting to a server and something is wrong, start looking at all the things that can go wrong there. So focus on eliminating anything that could be wrong on the client side. Maybe you're not going to the right host. Maybe you are not sending the right request or not processing the response in the correct way. So check, are we connecting to the right host? Do we send the right message? So look at logging, or maybe you can inspect network messages that are being sent. Are we receiving a response? Yes or no? And this is not much different from local debugging, since you're still debugging something on a client side, but try to get as close to the action as possible. So if you receive a response, try to log the response that you receive as close as possible to the network boundary. Because if you instead log a toString operation on your deserialized Java object that was a result from this message, there might be a problem in the deserialization there. So tools you use are your IDE, a debugger, and logging you can add here. And then it gets interesting because now we're actually going to cross the network boundary to the other service. So first step is we start inspecting DNS. Make sure you know what IP address the hostname you're trying to connect to resolves to. Because it might be that you have some local DNS configured. You have something configured in your E2C hosts. There might be a DNS cache involved. Could be all valid reasons why you're not actually connecting to the right IP. And also verify that the IP address you should connect to is actually happening at the client. So how do you know? It's time for a short demo. So let's check out, I don't know, we're going to verify whether we can reach the OpenValue web server. So one thing I can do is I can look up the IP address for the OpenValue web server. Let's say www. All right, so it's 3.121.28.58. How about how do I know that this is the right address? Well, I need to query the authoritative source for the OpenValue web server, which I can do by looking up the NS record. So there's no NS record for www because it's on the top level domain. So this is hosted probably at Antagonist, which is a small web provider in Enschede. So now I can ask the IP address for OpenValue.nl to this name server. And this name server is saying, well, it's the same address, so probably this is the right one. I can also check the domain registration for OpenValue.nl. And here it should also tell me what DNS servers are configured. Same ones. So then I now can check again. If I query this name server, That's probably the same one. All right, so in the domain registry, there's a domain name server listed, and if I query this name server, I get the same IP address. So I'm pretty sure that this is the right address. I can also look up the IP address if I want to know something more about the IP address, because IP addresses also have whois registrations. So in this case, I'm seeing that this is registered to Amazon. So probably the OpenValue web server is running on Amazon somewhere. There are also other types of records, for example, text records. So text records allow you to set random text in DNS records. These are sometimes used to set, for example, sender protection records for emails and stuff. So let's check out what the text record is for the hostname dns.google. Let's first look up what dns.google is. No, I always make this mistake. DNS.google. This has two addresses, 8888 and 8844. Who knows what this is? Yes, the name says it already. These are the DNS servers that Google publicly makes available that you can also use to speed up internet in your home. But what if you look at the text record here? Any expectations on what should be in here? What should be in a text record for DNS.google? Well, there's a sender protection thing here, it's from mail. And there is a link to an XKCD comic, which is interesting. So let's check it out, what's in there. The rumors are true. Google is shutting down everything to focus on their core project, the 8888 DNS server. So this is probably the sense of humor that the average DNS engineer has, I would say. So now we know that which IP address we are going to connect to. We can try to find out if there's actually a valid route from our machine or from the source machine to this IP address. So we're going to verify that we can reach the target machine, but still on a network level, not yet on a protocol level. So we're not going to talk about TCP yet. We're going to focus on can we reach the target machine. So let's check out, for example, for Google. Can I ping google.com? Yes, so I'm getting ICMP replies. So probably there is a route from my machine to google.com. Or if we do a trace route to google.com, then in this case I'm going through a, well, there's not so much interesting information here. Let's look it up from my home. Because I think there's a bit more to see there. So this is a Linux box in my home. I'm going to a trace route to www.google.com. So it's saying here that we're going to my security gateway, and then through this IP, which is my Ziggo modem. Then we're going to some machine from AES33915. We can probably look up what this is, but not really relevant for now. But looking at this is probably a machine in Hilversum, which makes sense because I live in Maarsen, and well, if you there is a somewhat indirect path from Maarsen to Hilversum to Amsterdam. So the second machine is we're going to some machine in Amsterdam, probably. This one is also in Amsterdam, this one's in Amsterdam, and then here, well, there are no host names anymore, but the final server reach also has AMS in the name. So probably there's an edge location for google.com hosted in Amsterdam somewhere. So we can look up this IP address to see who owns this. It would be funny if Amazon owned it, but probably not. No, Google owns it. So this is an IP address in some allocated range by Google. So now we know that we have we can actually reach google.com. There's a route going from my home to Hilversum to Amsterdam to Google. And some other interesting tools that you can use are a web-based tool which is called nslookup.io. For example, openvalue.nl. And nslookup.io can show you a couple of different records. So text records, there's also an SPF record in here, the name servers, the mail server record. So you can know from here that probably OpenValue has their email through Office 365. Some other info, and you can also query Google DNS for the entry, OpenDNS, and the alternative result, which is probably when it connects to the authoritative name server for our domain. And local DNS, you can select a couple of different regions. And there's another tool that's useful, and this is DNS Checker. And DNS Checker is a tool where you can check the results for a DNS record in different regions. So let's also check the web server. And now it's checking the DNS propagation over a couple of sites in the world. So this is all green, so it's resolving everywhere. You can check to what IP it resolves. So if there's anyone ever complaining it doesn't work from St. John's in Canada, okay, then this tool can help you to find out what the local DNS resolver is returning for your hosting. All right, so tools you use here are host, which is a DNS tool, NSLookup, which is a DNS tool, dig, where you can go in a bit more detail, whois to look up domains and IPs, ping to check if you can get an ICMP response, traceroute to check the routing to the internet, and then the two websites I just showed. So next step is to check whether we can actually make a connection. So now we know that there's a valid route. On a network level we can connect to the target machine. Now let's see if we can connect to the actual port that we're trying to reach. So can we connect using typically a TCP connection? If we cannot connect, do we get a reject or a drop? So reject is where the firewall actively rejects the connection. So you typically get a connection refused, or there's nothing running, there's no firewall. A drop silently drops your packet. So then the connection won't build up. We'll see this in a bit. Does the connection open? Does it stay open? Sometimes the connection opens quickly and closes right after, which typically means there's some firewall in between or something else that's preventing you to connect. Are we talking TLS, so is it an encrypted connection? Typically, I hope not, because if it's encrypted, it's typically a bit more difficult to actually debug, but we can still check firewall stuff. Can we connect or not? And what is the connection speed? Is the speed fast enough between our machine and the target machine? So tools we're going to use here are, for example, telnet. So let's try out if we can telnet to OpenValue.nl port 80, because we want to connect to the web server. Okay, we get a connection and we can try out if we can, I don't know, get an HTTP response. Yes, so we get some HTTP response, so we're pretty sure that we can connect. What if I try to connect to port 81? Now it says trying. So this typically means that I either can't reach this IP, but I already know that I can reach it. So then it's probably a firewalled port. If we connect to a local machine, port 81, they say connection refused. So it's either firewalled with a reject, or there's nothing listening on there. Let's see if we can, well, we can do, for example, a small speed test to check the internet connection on our client machine. In this case, by making a request to the FTP server of the University of Twente, or downloading with 70 megabyte per second, I think. Yes, 70 megabyte per second, which is about 600 megabit, which should be fast enough. But how about if I want to check the connection between two machines? See how fast the connection in between is. Well, there's a tool called iPerf that we can use here. Let me zoom in a bit. So iPerf is a utility that starts up a server on one end that you connect to with a client on the other end, and it measures speed between those two hosts. So I can say iPerf min server on this host, and on the other one I say iPerf min client to this IP address. So it's now connected and it's now transferring at 17 gigabit per second, 18 gigabit, which is quite fast. Considering that I only have a 1 gigabit network at home. So why am I getting speeds of 18 gigabits when I have a 1 gigabit network? Any ideas? Yes, I'm cheating because the one on the right is a VM running on the one on the left, so it's a bit faster. I had another Linux box where I could demo this over the network, but the other day my son came down and said, "Daddy, what's the noise?" I said, "No idea." So I woke up and hear, and basically the fan was full of, I don't know, dust or something. So I turned it off. So that's the reason why the demo is now less impressive or more impressive, depending on. And if you cannot connect, it can be either two reasons. It could either be a firewall, well, it could be three. It could be a routing issue, but you tried this in the previous step. It could be a firewall issue. Or it might be a wicked network issue in a software-defined networking environment in a cloud provider. So I've seen multiple times in different cloud environments that you thought everything was set up correctly, and when you connect, you cannot get a connection. I've seen this at AWS, but also at a private cloud solution. So I worked with a cloud engineer there, and his favorite saying was, "Ein kaltes Boot ist immer gut." So what it would just do is reboot the machine, which then reinitializes the network stack. And typically this was enough to solve most of our network problems, which is strange, but true. So tools you use here are Telnet or NC, which is Netcat, that you can use to also to check connections, curl to make HTTP requests, and iPerf to measure speed. Next step is we're going to look at the traffic or messages that we're exchanging between client and server. So first question is, do we send the right request? How do we know? Well, measure it as close as possible to the network boundary, either on the client side or when you're only developing the server, on the server side. Do we receive the right response? Same thing. How do we know? Well, by inspecting either network data or by logging whatever we are receiving or sending. How do we handle TLS? So if there's TLS involved, it can be a bit harder to investigate the problem. So you can either use a TLS proxy on the client side, where you're not making the client make the connection directly, but go through a proxy where you generate TLS certificates yourself. Or you can try to figure it out at the server side. Typically, web applications have some kind of TLS termination. So it either terminates at a load balancer and then goes over an HTTP connection to your server, or you're running some kind of Nginx or Apache server that terminates TLS and then goes to your local unencrypted port. If it's fully encrypted, then it takes a bit more work to find out what's being sent. And think about whether there are any load balancers or proxies in between, and try to find out whether they are doing anything to your requests, adding or removing headers, terminating connections, etc. So tools you can use here are, for example, curl to or telnet to make HTTP requests. So I think I already showed this, but I'm going to show you again. Going to telnet to the OpenValue web server, port 80. So we're going to get the root. We're talking HTTP 1.1, and the host is www.openvalue.nl. So it says it's moved permanently, and we need to be at HTTPS openvalue.nl. Okay, sure. I'm not going to type HTTPS in the telnet connection, but we can try by using curl. So here's some information about the certificate. It's valid until 12 November. It's created by Let's Encrypt. Certificate looks okay. Then we're going to talk HTTP2, and this is the request we're sending, and this is the response we're getting, a 302, and it says you need to be at openvalue.eu. Well, let's try out what happens when we go there. Now we're actually getting the HTML back. So we kind of saw like which requests we were sending and the response we were getting there. But it would be interesting if we were able to debug this on the server side, right? So let's check this out. I'm going to log into the OpenValue web server. And let's switch to the root account, because I'm going to inspect network traffic. And I'm going to use TCP dump to inspect any calls that are being done to TCP port 80. And now I'm going to make the same curl to the OpenValue web server. So here I see the exact request that's being sent, right? So this request gets slash, and the response I'm getting is, this is the response I'm sending. So if I would be sending like any weird request here, then this probably would also show up here. I'm doing a get request to this, and my user range is this curl. So you can use TCP dump to, on the server side, check out network traffic that's being sent on unencrypted ports. And in terms of HTTP response codes, well, there's a pretty simple rule. If the response code starts with a 2, then everything is okay. If it starts with a 3, it means go away. It starts with a 4, it means you screwed up. Starts with a 5, it means I screwed up. So that's a nice donkey bridge to remind. Well, it's not called donkey bridge, but if you don't, you know what I mean. So tools you use here are curl to make requests, Wireshark or TCP dump to check out network traffic. The network tab in the browser could be interesting. A neat trick is that you can copy most network tabs in a browser to as a curl command. So let's say that we would open the OpenValue website, and I'm going to my inspect tab, and I'm going to my network tab, and I'll make a new request. Let's say that something is wrong with I don't know, the main CSS. I can go to copy as curl, and now I have the exact curl command on my copy paste button that will send exactly the user agent, all the headers that I'd sent, and probably I would get the same output back. But this can help you, for example, if you want to debug something, a request that you need authentication for. If you are logged in your browser, you want to debug something with curl, then you can typically use the call in your browser that has your OAuth token or whatever, copy as curl, start editing the curl request, and then from there on start investigating the issue. So this is a neat trick to debug authenticated connections. Tools you use here are curl or Wireshark TCP network tab I just showed, and if you're doing anything with TLS, you're going to use a man-in-the-middle or TLS proxy to decrypt the traffic. Step 7 is debugging the server side. Inspect the remote host, see what you can do there. If it's a VM, can you log in there? If it's a Docker container, can you gain access to this container and log in there? Or otherwise, can you use any tools that are being offered by the cloud provider that you run your Docker container on? See if you can attach a remote debugger. It's not something that I see a lot. I don't do it a lot, but if you want to know how it works, my colleague Wolfgang presented a talk about this, which is up on our YouTube channel. You can basically jump over an SSH tunnel and then connect a remote debugger to a Java application running on a server somewhere. You might want to connect a profiler to see if there's anything going wrong or the machine has any memory issues. Or you can use a neat tool called strace. How many of you have heard of strace before? 1, 2, 3. Okay. strace is a Unix debugger. So it's a debug tool to debug probably libc based Unix applications. Well, not really, because you also debug Java applications with it. And you can basically attach to a running Linux process and read the output from it. So in this case, let me check out what the web server process is here. So there's Nginx running. So this is the worker. So this is this process ID. So I can use strace to connect to this process ID. And now we'll show anything that happens on this process ID. So if I do a curl port 80/this, I see some things flying by here. So you can see here the response are being sent. It says HTTP 301 move permanently, and this is the request, but it's being cut off here, right? So I don't see the entire request, but there's a string parameter that shows how long strings can be. So let's say we can have a 1 and a couple of zeros. If I now do the same request, then I get the entire response that are being sent. But how is this different from whatever I was doing with TCP dump? Well, let's try a HTTPS connection. And then, well, you see a lot of things flying by here. Let me start it again so we know where to start. Okay, so let's start at the top. What we see here is, if I scroll far enough up, well, we should see the request somewhere over here. There's a lot of, well, this is the certificate that's being sent. So it says, let's encrypt here. It's the certificate for OpenValue.eu. And then once the TLS exchange has been completed, there should be a request somewhere. Hope we can find it. It's going to here read the index.html. So probably the request should be somewhere up top here. Well, not going to bother you, but you can, I can assure you that it should be somewhere over here. And here we see the response. So here it's saying, hey, I'm reading this file, probably from disk or from cache, and this is the HTML response that we're sending. Well, even though this is a encrypted connection. Why is it in here? Well, because in the Linux process itself, the data is not encrypted. So we can also use this to make a really simple request logger. For example, by only looking at the get/requests. So now it says get/. What if I would add something like this? It says get. So even though these are encrypted connections, we can still look in memory at the Linux process running on the server. Obviously, you need to have root access to be able to do this, otherwise it will be kind of a security issue. But there is a neat trick to, for example, find out why a process is hanging, if it's waiting on somewhere, if it's trying to read a file or whatever. So tools you use here are SSH tunnels to jump to the machine that you want to jump into, a remote debugger, a profiler, or something like strace. So hopefully you've then found the problem. And if not, you need an extra step, but I'm not going to tell you because I don't know. So then if you found the problem, it's time to document the issue for future reference. So document the timeline. When did we first find out? How long did it take for us to find out the problem? How long did it take for us to restore service? What did we see? Why did it happen? What's the reason? What was the impact? Did it impact users? How much? Did it impact 3.5 billion users for 7 hours or not? How did we find out? Was it logging? Did somebody call us? Did we see something? What did we do to mitigate the issue? Maybe there was a short-term mitigation. Or what would we do to fix? What should we do to prevent this issue from happening again? And this helps as a structured approach to write down what happened, but also to share it to others, present it to your team, and hopefully prevent this issue from reappearing. So tools you use are a whiteboard and any documentation system you have. So Jason Cahoon, the author of the Google chapter in the case engineering book, says if you really want a reliable system, you have to understand its failure modes. You have to actually have witnessed it misbehaving. So we're going to share a couple of war stories. Not all of them because we don't have that much time, but I'm going to share 2 or 3. So the one where it worked half of the time. This was a system where you could generate a PDF. So you would click a link, system would generate a PDF, and then you could download the PDF and look at it. So this worked on the test environment, and then we went to a staging environment, and it worked half of the time, about half of the time. Any ideas what could be wrong? Load balancing. Yes, there was a load balancer, but both nodes were healthy and doing fine. There were 2 nodes. Yes. Different setup on both nodes? No, they were set up exactly the same. No sticky sessions. Yes, there were no sticky sessions. So the load balancer was randomly routing you to another machine. So that's part of the problem. Well, it's not a problem that this happens, but if your application is built in a certain way, it can be a problem. So I'm referring to your application being stateless or not, right? In this case, the application was not stateless. So the person who had built this had found an example on the internet that could generate a PDF and write it to disk. And then conveniently, he wrote another piece of software that could read the PDF from disk and send it back to the client. But this was implemented in a way that you would press a button, then a PDF would generate, and then it would show you a link on the screen that you could click, and then you could download the PDF. So what would happen is you click, it generates, you click again, you get routed to the other machine, it's not on disk, you get a 404, doesn't work. So it worked half of the time, because if you're lucky, you're routed to the same machine twice. The same thing can happen when there's an issue, for example, one machine is down or there's a firewall issue or something, but then the problem is it gets a bit more clear because you get an error half of the time. This is my favorite one. This happened at a school. So I was building software for an educational publisher, and we got a complaint that loading content in a lesson like images and videos was really slow. So we said, well, it's probably you because we run on AWS and we have loads of bandwidth. So is your connection fast enough? Yeah, sure. Here's my speed test. The system administrator at the school showed, and we have like 500 megabits. Okay, that's pretty beefy. So are other sites fast? Yes, other sites are fast. Okay. Well, then we need to come to your school to see what's going on. So we went there. It was all the way to Zeeland, so it was quite a long drive. So we get there, we talk to the system administrator, and they show us like, okay, this is the speed test, it's all fast, but your application is slow. So okay, let's see. So they called in a little girl with an iPad who was doing a biology lesson in her class, and she showed us that if she was scrolling to the page, the images would load pretty slow. Like it could take like 10 seconds for something for an image to load. Well, that's weird because they're on a content delivery network. And they have patch locations everywhere. The connection is fast enough. What's going on? So okay, thanks. We've seen the problem. Let's investigate. So I connect to the network, and I check out some connection speeds, and indeed they're all pretty fast. And then I start trying out to connect to the content delivery network that we're using. So I'm doing like, I don't know, a curl or a ping. And the first thing I notice is that it takes quite a long time for the request to initially start, and then it's pretty quick. So, okay, that's weird. Let's try some DNS lookups. So I tried some DNS lookups, various sites, and they all took like 10 seconds. So that's quite long for a DNS lookup. You typically want like 10 milliseconds or something. So, okay, weird. What DNS solution do you use here? Or what provider do you have? Yes, we have two, we have two internet providers. Well, that's interesting. So why do you have two? Yes, because if it's down, we want to be able to use the other one, and sometimes we use both. And okay, but thinking about DNS issues, how do you handle DNS? Because typically a DNS provider only allows you to use their own DNS server. So if you're going with DNS with internet provider B and using DNS server A, typically won't work. No, that's right. But we solved this. Okay, so how did you solve it? Yes, we use Google DNS on all our machines. So, okay, still not a weird choice because Google DNS is pretty quick. So then I tried to some more requests and it was still really slow. So, okay, weird. How many clients do you have in the network? Yes, about, I don't know, 3,000 or something. And they're all connected at the same time now? Yes, they're all doing lessons. And are all the applications you use web-based? Yes, most of them are like web-based with HTML5 or something. Okay, then probably you're doing quite an amount of HTTP requests and therefore quite an amount of DNS requests. Yes, probably. And then I started looking like if there any like rate limiting or something by Google DNS. And it wasn't really, there was no information at Google, from Google about this, but there were a couple of forums where people were suspecting that Google had implemented rate limiting on their DNS server if you were doing more than 3,000 queries per second, which we were probably doing. So okay, that's weird. So let's try OpenDNS, which is another free DNS provider. So they switched to OpenDNS. I said, okay, let's get the girl in. We're going to see if it's now quick. So the girl comes in, it's still slow. I said, oh no. And I thought, wait, the DNS entry is handed to you as part of your DHCP response. So probably she's still on our previous DHCP lease, still has the old DNS server. So can you reconnect to the Wi-Fi? So she reconnects to the Wi-Fi and she now scrolls through the application. And it's lightning fast. And the system administrator is, wow, they really got, well, what's it called? It's not called chicken skin, but goosebumps, right? I have a goosebumps moment. And so what I learned here is that, well, obviously it was DNS, and it's DNS more than often than you think. But what I learned here is that from the perspective of our client, the school, our system was slow. Well, it was something that we didn't do. It was even in a service that we didn't even manage. But for them perspective, it was still slow. So get back to the picture of what happens when you type google.com. Well, all kinds of systems you don't manage that can still have influence on the experience of your end user. Yes. Why were the other sites fast? Probably because they were only doing like one DNS lookup and then pretty quick. Well, in our case, we were fetching like loads of CDN URLs, so probably we were affected a bit more than other sites, or they were in a local cache or something. So various reasons, but indeed they were not all really fast, but the couple of ones I checked were reasonably fast. So the one with breaking news. This was breaking news in different ways. So I was onboarding another colleague at a project, and I was showing them the monitoring dashboards we had, where with average response times and how many nodes were in service, etc. And I showed him the dashboard, and he said, "Hey, does this line mean that there are now 0 nodes in service?" I said, "No, that can be right. There must be an issue in the dashboard." So at the same time, my phone rings. It's head of application management. What's going on? I said, I think we have 0 nodes in service, but that's not how it should be. So I'm going to investigate. So we go investigate. And it turns out that all our applications are indeed down because the health check is failing. And we're like, so why is the health check failing? So we're looking at the logging of the health check. And the health check is saying that one of the services that the system is built of is not responding in time. And that's why it took the system out of service, because it was set up in a way that we would check all the different services, and if one of them wouldn't respond within a couple of seconds, we would say we're not healthy and we go down. So this happened with all our 4 or 8 instances, and the service that was the culprit was the analytics service. And the analytics service was a service that we would send some events to, and then it would send events to the analytics collector used by the company that our company was part of. And it turned out that this analytics collector was also used by the biggest news website in the Netherlands, I think nu.nl at the time. And there was something going on, and I don't know, a couple of 100,000 people using the mobile app had gotten a push notification about breaking news, and it would go to the site all at the same time, and the analytics collector would be overloaded. Which as a result, in the analytics service on our side, all the requests to the analytics service were timing out. So we had a big queue of outstanding requests that weren't being completed because we didn't set a timeout, so it was probably timing out after 60 seconds or something. And in the end, this would cause the service to go out of memory, not respond to health check anymore, and go out of service. So what did we learn here? Think about timeouts, obviously, because if we would have a shorter timeout, then probably our queue would have been had more room for more requests. But also, should the application go down if we cannot send analytics to an analytics system? No, not really. So then we started thinking about, okay, if this service is down, this is not part of the core functionality of our application for our end users, okay, then we shouldn't take the application out of service. But because it was so busy, I think in the end we ended up spinning up like 20 machines, shutting the web server down on all of them, waiting for the application to start up, starting up all the web servers at the same time again so they could start handling requests at the same time, and then barely have enough stretch room in the queue to keep stuff running until the analytics service was fixed. So it was an interesting issue. To summarize, the steps I showed you were observe and document, create a minimal reproducer, debug on the client side, check whether DNS is resolved correctly and whether you have a route to the remote server, check the connection on a network level, inspect any traffic that's going back and forth, debug whatever you can do server side, and then the wrap up and writing down a postmortem for those who come after you. That's what I wanted to show you, and I'm happy to take any questions either from you or from home.
Yes, no questions from the audience online yet, but they can still ask their questions if they like. So I don't know if anybody in the audience here has a direct question for Bert Jan. Otherwise, Bert Jan, I'm really curious. So you, first of all, really interesting talk, and it once more made me realize how much you actually need to know as a developer to understand how your application actually runs. And well, you've shown us that you have impressive knowledge how to debug stuff, but it makes me wonder, did you ever encounter a situation where you were not able to fix it and you still wonder up until today what happened and why it didn't work?
That's an interesting question. There have been situations where I didn't really find the issue yet and the problem was resolved before I could find out the issue. So I think one of the longest issues that I had was with that even ruined kind of my weekend, because I was testing a connection to a credit card processing company, and we tested this all on our acceptance environment. This was all working fine, and there was this communication going back and forth over a URL with URL parameters, etc. It was all working fine on our acceptance environment. Then we go to production, and the project manager used that credit card to do the first symbolic payment, and then it failed on the request back. So his money was gone, but he didn't purchase anything in our system. And this happened on Friday afternoon. So I stayed in the office until late. I couldn't figure it out. I was a bit irritated for the entire weekend because I hadn't been able to resolve the problem. And then on Monday morning when I was in the shower, I got an idea like, okay, maybe there's something different between acceptance and production. So then I started fiddling out some of the parameters, and it turned out there was an optional parameter that if you didn't set it on the acceptance environment, it was given a default value. But if you didn't set it in production, it was ignoring this parameter and something would go wrong. So there was a difference in specification between acceptance and production. And I found this out by methodically trying out all the different permutations of parameters and finding out that it was a problem. So then I phoned the other people and I said, wow, it's interesting that there's this optional field. That is indeed optional, but if I leave it out, it works different in acceptance and production. Yes, but that's something we already know. I said, yeah, but I would have liked to know it before, right? So that was kind of hard issue because it was something I couldn't really see because it was happening from the server side and I could only observe my interaction with them from my side.
So did you lose any money while debugging?
The project manager lost quite some money, but well, he did small transactions like €1 or something, but we needed at least 50 tries. So.
Oh wow! So still no other questions. So being a bit lazy as I am, I now learn the structured approach, do some debugging. Is there also a tool that can just do the steps for me, maybe, but just feeding the URL and doing the curl stuff and all the other things that you showed us?
I don't know. I haven't found one, but on the other hand, I enjoy fiddling with systems and trying out myself. There might be tools that do this. I'd be interested to hear about them, because if I can automate myself, I'm always in for it.
All right, cool. Well, thank you very much for your talk. A round of applause for Bert Jan. So we now have a break of 10 minutes, and then we'll continue with the next talk by Roy. Thank you very much. Hoe laat? Ja. Even kijken hoe lang. Nou, ik wel, ja, 5. Welcome back, everybody. On to the next talk. So the next speaker, Roy Honders. I've known him for approximately 5 years, and Roy really loves technology. He's pretty much an all-round guy doing front-end stuff, mobile stuff even, I think, Flitsmeister, and cloud stuff, and well, apparently also some cloud vision stuff, image recognition, machine learning kind of things. And well, the fact that he spent a few weekends learning how it works will probably result in a very interesting talk. I'm really curious to hear more about it. So the floor is yours, Roy. Take it away.
Thank you, Roy. Yeah, small correction there. At Flitsmeister I did do backend stuff, but for some other projects I worked with Flutter, so I did do some mobile development. So you were correct there. But yeah, so this is my talk. What I learned from spending a few weekends with Google Cloud Vision, working on one of my personal projects that I started 2 years ago, and I completed it, I think, in a few months. Didn't work on it every week. I'll be taking questions anytime, so if something pops up that you really like to know, I'll answer it, and maybe if I'll answer it later in the presentation, then I'll let you know. So first, something about me. Roy did a brief introduction. so mainly focused on front end and cloud in my day-to-day. I work at Luminous, but I'm here on my own behalf. I'm interested in entrepreneurship and investing, and I also like reading books and learning languages. So not only development languages, but also spoken languages. I also have my website and some social media, but all of those are on my website. So if you ever want to contact me, you can go there, find my WhatsApp, Telegram, whatever you want to contact me on. So first, a question to all of you guys. Who has experience using cloud technologies? All right, that's almost everyone except a few. And who has done anything with cloud vision or AI? Also a few. Okay, so this is going to be a little bit more introductory, but hopefully my project will be interesting to you. So let me talk a little bit about my project. So my motivation to do side projects, I've done multiple, but this was the only one I actually completely finished, is to learn some new technology, so I always stay up to date. It also makes for an interesting presentation, and this one I also use on a daily basis. Well, not literally daily, but I use it every time for the purpose that I built it for. And at the time I read a book called Ultra Learning, and I wanted to apply those principles, meaning I wanted to do something practical and learn as much as possible by just doing, and then afterwards like reading more about it and yeah, like fully grasping the new technology or whatever you're learning at the time. So that's why I had the idea of doing a side project. And then I came to the idea when I started working. Actually, I got a company lease car, and it wasn't fully, the tank wasn't completely full. So I had to go to the gas station quite quickly. And then the machine, after like using my card, asked like, do you want a receipt? And I did get a company gas card as well, but I was curious because I never owned a car before. Would it be efficient to get a lease car or buy my own car and pay for the gas myself? So I thought, oh, it might be interesting to take the receipt, maybe put it in a spreadsheet, and then that way see how much I spent like a month or per year, how much I would have spent on gas. So this is an example of what that would look like. There's also a few other interesting things like price per liter that varies all the time. So that way I could also track that, and I'll go more into detail which ones were interesting for me. But then the day afterwards I went back to the office and I was just kind of thinking out loud like, yeah, is there a way to read text from a receipt? And while I was saying that, someone said like, yeah, there's optical character recognition. And I was like, oh wow, cool, I've never heard about that, let's look it up. So I ended up installing an app on my phone to try it out first. And then I took a picture of the receipt and checked out the results, and it was pretty accurate. And then I was already excited, like, hey, let me look into more technologies to yeah, to kind of see how I want to automate this process, because I was like typing all these values manually. But I thought, yeah, maybe technology can do this for me, but I don't know yet how I can do that. And back then, I never heard about OCR, and I think some other people might also not have known about it. But these days it becomes way more popular to like use cameras to detect text. Like last week I saw an update from iOS 15 for iPhone, where the new camera systems, they have a lot of features baked in, where you can like detect text while opening the camera app, or after you shot a photo. You can like select text in your gallery or in your device, and you can translate, copy the text. So yeah, that's really useful for like students who still use books and they have to make notes and stuff like that. But you see, it becomes more common. But back then, I was like very excited because I've never heard about like how well those technologies work already. So I did use kind of a project method, but I only learned in hindsight. There's a lot of project methodologies like Scrum. I'm sure you're all familiar with that one. But in hindsight, this was pretty close to throwaway prototyping, where I just iteratively build a prototype based on all the technologies I found online. But also, I ended up throwing away one prototype because I thought of something better in the end. So yeah, that's why it was more in hindsight that I apparently chose this one. And also because I fully developed this myself, I didn't need any backlog or all of the other things that come with other project methods. So then I'll go into the results. There's two solutions that I built. I'll show you first solution 1. This is something I hand drew after the fact, so this is not like architectural design. This is just to kind of illustrate how the system works in a few steps. So basically, you start here as a person taking the picture from the receipt, and then you upload it into the browser application that I built, which is happens to be an Angular application, but that's not too relevant. It could have been Vanilla.js or whatever, as long as it can import TensorFlow, because I built a model using Google Cloud Vision, and after you train the model, you can download it and then import it using TensorFlow. And then I did have to do some coding to receive the right properties from the object that TensorFlow generates, but other than that, you don't really need to do too much in terms of coding there. Then I send it to a cloud function that's will use the original image and like got all the boxes of the interesting text that the model found. Then it will do that 6 times because I was interested in 6 pieces of text that appeared in the receipt. That would be the date, the time, the current mileage of my car that you have to type into the machine as well. And it will also be reflected on the receipt. So that way I knew what mileage my car was on. The price per liter I mentioned, the volume, which is the amount of liters you got at the time, and also the total price, which could be derived, but it's also on the receipt. So in total you have 6 interesting data points on the receipt. And then for every box that was detected by the TensorFlow model, I would cut out a small image, which would, for example, have the value 26.34 for example, the volume. And then that would be sent to Google Cloud Vision OCR. Google Cloud Vision OCR is an existing service by Google that you don't have to configure or anything like that. You only have to say what type of image you're sending and what kind of result you want back. And then it will give back the text to you. So it just gets some raw text based on an image you sent. Then that text goes back into the cloud function, and it has the appropriate label still attached to it. So based on the detection in the model, you would still have your value connected to that. And then I would create some JSON object of 6 values, and I'll put all of those in Google Sheets in the right column. So every key in the object would have a key in the Google Sheet. So I'll just have like the top row of my Google Sheet. Those names couldn't be changed unless I changed my my code. So if a non-technical person was interested in this document and he was like, "Oh, this is an ugly name," and he would change the row, then it wouldn't work anymore. So I think now it's about time to show you a little bit of how this all worked. From the first solution, I don't really have a lot of documentation because I was really more into developing and not really like documenting my whole journey. But I did keep this this part. I recorded it because I was at the time super excited that I saw some results finally. But you see a terminal window here in the middle of the screen, where I just run the JavaScript using Node. But normally that would be the cloud function in the image I showed earlier. So here on the left you can also see the spreadsheet with all the columns in bold letters. And on the right you can see the receipt, where the image would already be scanned by the model, and it would draw all these boxes around the date, the time, the volume, and all the other things I mentioned previously. So I'm gonna hit play right now. Now you can see it will execute the command, and then after it's done on the left you should see that the spreadsheet will be updated. So now you can see all the values are added. So basically that was me testing the code that would run in the cloud function. And then I have some other stats that I will just extend. Those are derived from the raw data. So that was basically how the initial model works. And I can show it a little bit in Google Cloud as well. So in Google Cloud Vision, you see on the left you have a dashboard, some datasets and models. So if I look at datasets, the first time I went here, I pressed create a new dataset. I didn't know which one to pick, but I later learned that the first one, single label, is for classifying images. So for example, different types of clouds or different types of trees, if you want to work with that kind of stuff. You also have multi-label. Let's say you have a dog and a cat in one image, then it could classify multiple labels, like there's a dog and there's a cat in one image. But I was more interested in object detection, where in my case the objects were pieces of text. So that's kind of how I approached that, by creating that kind of a data set. And then I can also show you what that looks like. So you upload a bunch of images, and then for every image you can manually draw boxes using your mouse around, in this case, the time. It's all in Dutch, so I probably think it's too small for the people at home anyways. You have the dates, the volume, the price per liter, and the amount, and the mileage, the kilometer stand. And yeah, this way I trained my model. I did use my own credit card, fun fact, but I did get some credits as well by, after activating Cloud Vision. So that those got added to my account. And that way I could do it for free, but there was also a small risk that if my model was training for too long, yeah, that I could have spent like $16 per minute. So that's was kind of interesting to see like how long would it run. So I was keeping tabs on the time, seeing like calculating how much credits I had and how long it would run. I think in the end I spent like 200 euros of credits, and I had like 250, so I was within the limit. But then I also realized that it would be a limitation to do it this way, because I think usually these kinds of models will be used for maybe millions of images at a time, and then creating one model and not iterating over that. Whereas I was collecting the data like every week or every other week whenever I had to fill up my car, I got one more receipt. So it's a very small data set. And also I wanted to kind of use this iteratively. And that's not really a thing. Here you have to upload all your data at a time. So you literally have to create a kind of a new model to using all of the previous images as well. So that was kind of a limitation, but I wanted to point out here in the test and use section after it's done creating, which happened a long time ago, like I said. You can choose a few types of deployments, so to speak. You have TensorFlow Lite that can be used on mobile devices. You have TensorFlow JS that can be used in websites. That's the one I used. And containers. I'm not sure how that would work. Maybe you can like deploy a container and then create an endpoint that way. But yeah, this is the one I picked and used. So it ended up working quite well. But not every image would be the same, because if I went to another station, they had slightly different receipts as well. So it did work for most of my receipts, but not every one of them. So that's kind of why I went ahead and did a second solution. So wait a second. And it looks quite similar. Still have the same Angular application, but I decided to ditch the whole self-created model. And I was thinking, what if I do OCR on the entire receipt, and then I get all the text? And then maybe I use something like natural language processing. I've heard about that when I was researching a little bit, and I thought, oh, maybe I can find some kind of platform that does a lot for me. I ended up finding MonkeyLearn for that, and MonkeyLearn, kind of the name implies it. It's kind of works like magic, where you just click the interesting words in the text, and then automatically the platform will recognize it as like a recurring pattern, and it will try to find the same words or similar values in the text again. I think, for example, with the mileage, it was like 5 numbers. so it was in the tens of thousands. But when I got into the hundreds of thousands, it wouldn't recognize it as good anymore. So I think it was looking for a 5-digit number and kind of guess, oh, that must be the one. And that's kind of how I thought about it to begin with. Like, oh, a computer should be able to do this, but how do I hand code this? Like, if the number is like 5 characters, then maybe it's the mileage. So I was like, nah, I'm not gonna do it by hand. I'll find a third party who has researched this more. So it's kind of similar, but we do have an immediate upload to cloud storage right now. I only did that later on, where I wanted to keep all the receipts into to cloud storage, so that I could have a copy for debugging purposes or just to see all the images that I uploaded. And then the cloud storage will trigger a function whenever something gets uploaded. So that's how I trigger the whole process right now. And then I will do the OCR, the same one, only one time. So I did use the same code for that. Then it will get the raw text, and then it will just send it to monkeylearn. They will do their magic. It will come back to the cloud function. I get the same similar object that I had in my first iteration, and then I'll plop it into Google Sheets again, just like the last time. And this one I can actually demo, so I will do that right now. And what we see here is my beautiful zoomed in website where there's only a file picker, so it's only an input field in HTML. So all the magic is behind the scenes. And I will select an older image that is produced somewhere in 2020. Now if I go into the spreadsheet to 2020, you just saw it appear. So this one I tested just today as well. And now we have this row that I just did in this demo. I can also see here the image. So it seems like all the numbers are correct. And we also have the full text that I store, so I can later on use that for training purposes again. So that's kind of how this one works. So every time I get the receipt, I can immediately take a picture and throw it away again, and then upload it from my phone. And then I can at home at some point open the spreadsheet and like extend all these numbers over here to make the data complete, to use it for my purpose. And here you can see all the accumulatives, so I can see what the amount is for the whole year and stuff like that. So that's kind of what I use it for. And then I can also show you what the monkeylearn part looks like. So here there's a build and a run part. The most interesting is of course the run part, where you can see the text on the left that is outputted from the receipt. And you can see here on the right the detections it's already doing. This is one that's already in the system, so it already knows super accurately how to parse this one. Then we can also see the entire JSON object that you get back. And also the lists, which was more useful to me because I only wanted key and value. Then I can also show you train it. Let me see. Upload some new data. I think I hope this works because I collected 4 new ones. This is the only way to show you, because once it's in the system, it cannot detect them as new again. I'll just upload those. Should take a second. And then there's 4 duplicate ones, so I think I did upload them just before this presentation. And now I can train everything. So now I am basically the monkey that is clicking all the right labels. So for the amount, I pick this one, and apparently it's 2 times on this one. The price per liter is this one, I think. Volume is this one. Dates, let's find the dates. It's a little bit apart, but you can click all these together. And the time, and that was it, I think. Oh yeah, you're correct, thanks. And then the kilometer stance, it's probably, let me see. Oh, it's over here, but the number is somewhere else. I think it's, no, that's too big. This one, 105,000. So now on the confirm tab, I can see I have 7 labels selected, so that's pretty useful for you to verify the number, because I have the total amount twice, and then I hit confirm, and then can go into the next. But you can see here on the top bar that it's currently learning just based on the input I gave it. And I think if they extend this whole system, you could kind of have something similar to what Facebook has with flagging offensive content. They have people manually like updating the model, and then as they go, it will probably get redeployed continuously, so it improves all the time. So yeah, that's like the most advanced part about my system. It's the third-party software that I use, and this works really well, except for the one I told you about earlier with the total mileage on the car, where the number changed in the amount of digits. Then it didn't work anymore. So that was the demo. So how many lines of code did you guys think I used for solution 2? I see 5. I see a 3.
You already had the content, right? So you just need to rewrite the...
Yeah, but that's still included, and also like the cloud function and everything else. 42. That's a bit optimistic. Yeah, I think for maybe a normal application like handwriting everything, it could be in the thousands. But for this one, I wrote it in about 200 lines. So still not a huge code base to maintain, especially if you have like a smaller project within a company that requires this. It's quite easy. How many clicks? With oh yeah, in the beginning I used I think 40 images. So yeah, times 6 or 7, sometimes 5, because not every piece of text was readable. So yeah, but that's also quite nice that it kind of created a nice model, even though you don't always have every label visible in the text. So yeah, my main learning experience was comparing the 2 solutions that I built, and yeah, I have a few thoughts on that. what made this approach a lot better, the pictures are already stored because you immediately upload them. And that was pretty huge for me to kind of keep a nice, nice archive. The OCR is applied a lot less and less times, and that's a lot faster because it's only one call instead of 6 to the Google service. And as you can see, I can improve the model way more easily than the other solution, and the results are more accurate and they contain less errors, and that's mainly because of the way the receipts look, and not really because of the accuracy of the model. The model was performing quite nicely, but yeah, it had to be very stable. So maybe it's better for like a machine where you clamp something inside of it and have a stable image, and the layout is a lot more similar. And what made it a little bit worse, as you can see, my UI was kind of bland. And in the previous UI, you did see the image with all the boxes. So it was kind of nice to immediately see some results. And I also made the cloud function asynchronous. So I did get a JSON response back to the front end as well. So I could literally show the user if it was successful or not. So that's kind of what I'm missing right now, but at the same time, I usually just go into my spreadsheet and see if it worked. And I don't really keep staring at the UI anyways. It's more like fire and forget, just upload and then go ahead and do my my other things again. And also, I'm very reliant on the natural language processing. But at the same time, I could always swap that out for something else, like maybe also a Google Cloud service. But this was just an easy solution for me to work with. Then I have some reflections on this project. It's very nice to play with cloud technologies, even if you don't have much experience. At the time, I think I only created a few VMs and used some Docker containers, but I never used any AI-related technologies. And as you could see, 200 lines of code, in my opinion, is not a whole lot. So it allows you to create very nice and impactful software with minimal amounts of code. And I think that's also the future we're headed, like writing less and less code and the cloud's doing a lot more for you. And it's also nice to see that you can just throw away part of your project and completely start over with new technologies and create better results. And sometimes you are a little bit tied down to a certain solution, and you kind of have to put your ego to the side and be like, let's start over and create something better. So those are the key takeaways I got from the project and I wanted to give you. So that was it. Thank you.
So, thank you, Roy. You really showed us how you can do amazing stuff with cloud technologies with just a few lines of code. Well, as a software engineer, you can do so much great stuff if you just look at what's available at Google, Amazon, and Microsoft. I don't know if anyone in the audience has any questions at the moment. Yes, please.
You also, I think, the model you create, it can be also used for different various other things also, for like groceries. Did you try that other things with the same model?
Should I repeat the question to the audience? So the question is, could you use this same model for other purposes?
Yes.
I think you could do it. It's probably better to detect kind of what, create multiple models and then see based on a situation which model to apply. But I think you can add a multitude of labels and then based on what the text looks like, you could probably maybe have 18 labels and then 6 of those 18 are for that project and 2 are for another type of text. But I think logically you would make multiple models and then maybe have some type of filter. Let's say you're scanning a lot of documents for insurance company. Maybe detect first, is this an application form? Is this a claims form? And then based on that detection, detect the contents of a document. That's kind of how I would start building that, like how I would design it.
How many images was required to create the model?
I do not remember exactly. I think it was 8 for the Monkey Learn one. And for the Google one, I wouldn't be sure what the minimum was, but I think they say 10. I think I ended up also having like 8 or something and it accepted it because I duplicated the ones I already had and just uploaded them again under a different name because I didn't have enough data yet when I was starting out. But that also worked pretty good. You could see the confidence score was about 20% for every image then. So that's one of the values you get returned next to the boxes that have been detected. And I think anything under 20 was not usable, so I skipped those. I've just put in an if statement, like if the confidence score is lower than 20, don't use the value because the image had to be processed then. And everything above 20, it would be somewhere between 20 and 60. That was actually working quite well. Like the box would be fairly around the number for the new image that I had after that. So that was quite nice to see that it was only 8 images to really get something that you could use hands-on. So if you ever start a project, you only need a few images or a few pieces of text to build something cool, and then iterate over that.
Rosanna.
Yep.
Figure out how you read your receipts, like we read in Western population, we read from left to right and from top to bottom, and perhaps you, when your receipt is a bit well, not great, perhaps you would read more diagonal. Is there a way to configure that? Or
yeah. So to summarize your question for the audience, is there any other way to pass parameters for reading the images? I think there are options. I didn't need to use them because I think it was standard, like the normal alphabet, or I forgot the name, Latin alphabet, and so I'm not sure like what else I needed to do. I think only one parameter that it was a certain type of document, just a document containing text, and I think there's also a few other types of enum types of configuration parameters that you can pass to the call. But you'd have to look into the documentation to see the full list of things.
Now, the Monkey Learn platform, you recognize your values because of its values and not because of the information surrounding that value. I can imagine as a normal person reading a receipt, you look at your key to receipt value.
I had the 2 columns on the receipt.
Yeah,
Yes.
exactly.
Yeah.
I can imagine if you can configure the way you're reading your receipt that.
Oh yes. Yeah, I think I have looked at how Amazon did it, AWS. And over there they had a nice demo that you could use with like a proper document, so not really a receipt, but like an actual document with like straight lines for forms. And I think for forms they do have features like that where you could read also sort of key value pairs where the key is on the left and the value on the right. But when getting hands-on, AWS was not really my cup of tea at the time. I think they also had less languages at the time, so no option to select Dutch or any other language that you would need to use. So I hope that answered your question. That it's more for structured documents that they have a certain type to do that. All right. Any more questions?
I got an important question. So you wanted to find out how expensive it is to own a car.
Yes.
And did you find it out, or were you just going all in on the OCR stuff?
Yes, so they already told me this is the best deal you could probably get if you wanted to drive a more expensive car. And I think the only other option I would have is drive the cheapest car, but then that would only be for the monthly fees, but not really maintenance included. So
You have a good deal now.
yeah, there's almost no other option for me.
Okay, well that's
That's
good.
better. Yeah.
That's also a really nice finding.
Maybe public transportation, but then,
Yeah, you can walk, it's cheaper, I guess.
but I do use it personally as well, so then that's not really a good option either. So
Sure.
I did make a right choice, and this disproved it, so that's nice.
All right, thank you very much, Roy.
Thank you.
Thank you, online audience. This is the end of the meetup.